In this screencast, we're going to go through the rule management feature of the CyberSwift SIEM. So what you're going to see is two different submenus here. One is detection rules and the other is filtering rules. Both these are going to affect the components of your flow, and filtering rules will filter out events. So for example, over here you can see we are going to filter out DNS traffic, and since DNS traffic normally comes through the syslog worker from firewalls, etc., type is set to syslog. However, we can also influence what alerts get generated by the NIFI processors, and this is what we have under detection rules. So you can see we have a bunch of them over here. Some of them are pre-built rules that come from our internal SOC team, but you are obviously very welcome to create your own. So let's see exactly how this works. First of all, the thing to note over here is that all these rules are defined in a language called JSON. So I'm going to open a new JSON. JSON is this query language for JSON, and this is an extremely good site to browse because it gives you a really good overview and this playground so that you can use the learn how to use JSON more effectively. But for our purposes, the end goal is that basically we end up getting filtering data or alerts in real time as it passes through NIFI, rather than as it was before, where we have a query, a batch query, and we take some action on a schedule. Now everything is on an event by event basis. Let's dive in a bit deeper. So this is your typical Windows flow, right? You would get your events from Redis, they go into a Windows context worker, and then you either get a success or alerts. What I'm going to do is I added a flow file over here just for demo purposes, and the generate flow file is literally just generating an event that you would normally get through winlogbeat. And during normal operation, we get a flow file generated, and then it goes through success. So let's see how the detection rules are going to affect this, right? How we're going to influence it. First of all, let's say that we want to maybe filter out this particular event. Maybe we don't need it. So let's go to JSON. I am going to copy and paste the event into the playground, and we'll pick on something or other, right? So maybe we want to filter out computer name dvas, whatever that is, underscore xps. So let's build the JSON query as we go along, and this is what is nice. You see, as soon as I type in the field winlog, it's telling me, okay, what there is inside that object, and we are interested in this one here. So it's winlog.computer name, like that. Okay, so we found what we need. Now, these rules all expect a boolean, so either a true or a false, and obviously only the events which generate a true will end up being filtered in our case, or alerted. So what we need to do is say, listen, is winlog.computer name equal to the vas underscore x, sorry, 1 2 3 underscore xps, and we get a true. Fantastic. So let's copy this, go into our filtering rules. I'm going to create a new rule, Don't forget it was type Windows. Now we have 3 at the moment. These will increase: Windows, syslog, and audit beat. The name is going to be demo filter. That can be anything you want. James Pot expression is going to be one that I just built from the playground. And let's save this. Great, so the filtering rule has been updated and it appears there. Now, in reality, in production, this will take 5 minutes to, and if you will every 5 minutes will reload the rules that you define over here. So you don't need to do anything, you just need to wait for at most 5 minutes, and then you'd be able to see the results of your new rule. However, for this demo, what I'm going to do is restart Nifi in the background, which gives you the same effect, right? All the rules are loaded on startup or restart of Nifi. So let's wait for that to happen. And Nifi is back. So let's go here and let's generate that flow file again. Now, since we introduced the new filtering rules, we also wanted to make sure that you will be able to see those events that are filtered out. So these are, this is a new relationship that you'll see for Windows, syslog, and audit beat, the filtered queue, right? So if we add it here, we should now see that the event that's currently queued for processing should actually be filtered rather than go to success as what happened last time. So let's run this once, we'll refresh, and now we see that the event is actually filtered. Okay, so now let's do the exact same thing, but instead we'll create a detection rule, right? So we would expect that instead of seeing the event go into filtered, we will see it go into alerts. Let's go back here. Let's copy this, right, and delete this. Great. Filtering rule has been deleted, and let's go back to the detection rules. So let's create a new one. It's Windows. Yeah, why not? Let's make it severity low. The name would be demo detect, and I'm just going to paste exactly what I had before. So let's click on save, and the detection rule has been updated. So again, in the background, I am going to restart Nifi to simulate this 5-minute wait that should happen whenever we restart, whenever we create a new rule in production. So let's wait for that to finish. And Nifi seems back up, so let's do exactly what we did before. Let's run once. Great, so we generated our event and we should see it go into alerts. Let's run once again, and now we see the event went to success true, but it also generated an alert. And if we see what actually happened, we can see this flow files there. Severity low. The description is demo detect, just like we put it over there in our detection rule. And there's the original account. Sorry, there's the original event embedded in the alert for your reference. So that brings us to the end of this. It's a pretty straightforward system, and it basically allows you to define alerts or filtering rules without you having to go into the nitty-gritty detail of Nifi. Does this replace every other method that we have for alerting? No. For example, JamesPot doesn't yet support aggregations. Obviously, JamesPot works on a single event rather than a collection of events or an aggregation of events. So that is something that you still would need to do in certain cases. Plus, obviously, before we used to filter out events using or create alerts using JamesPot matcher. There are certain cases where you might still need to do this because, for example, you want to filter out alerts that are inbuilt into the processor, right? rather than a detection rule, or you would like to filter events before they reach Windows Context Worker, literally so that you reduce the load. Don't forget that Windows Context Worker is a heavy worker. It does a lot of checks, it generates a lot of um, alerts, it generates quite a bit of load per event. So if we manage to filter out events before we reach that stage, all the better. Thank you very much, and I hope this was useful.